All right, so today is going to start our unit on ratios. And our official definition of a ratio is that a ratio is a multiplicative comparison of two quantities. And let's break down what this means. So think about from back on our order of operations when we saying it's fun to do the GEMA. And we said that M stands for multiplicative. And there are two things that are multiplicative. So we have multiplication and division. So when we have a ratio, we are comparing two different things by either multiplying or dividing. Those are our two different options. So this will make more sense once we start looking at ratios, kind of getting there. So when we talk about a ratio, yes, it is a multiplicative comparison. Yes, we're talking about two different quantities, but it is also a relationship. And there are two different types of relationships that can be represented. The first type of relationship is what we call a part-to-part relationship. And the second one is a part-to-whole relationship. And we can also write ratios three different ways. The first way we can write them is by using the word to, T-O. We can write them using a colon, which are the two dots, or we can write them in fraction form. But no matter which way you choose to write it, it is important. In fact, it might be the most important thing that we talk about with ratios. It is important to remember that order matters when we write that ratio. So let's kind of put this all together in an example. So our example says in a floral arrangement, for every rose, there are two carnations. So what that means is when it uses the word every, that means for every one rose, I have two carnations. So the first type of ratio it wants us to write is that part-to-part relationship. So it says, what is the ratio of carnations to roses? So the reason it's a part-to-part relationship is yes, carnations and roses are both flowers, but they're not the same type of flower. They're not exactly the same thing. That's why it's a part and a part. Now, we said order matters when we write these ratios. So since it wants to know carnations first, roses second, that's the order we have to put it in. Now, because these are our notes, we're going to write them the three different ways. So let's start with the word to. So I know that in this problem, there are two carnations to every one rose. So it's a 2-to-1 ratio. If I write it as a colon, I would have 2, and then there's the colon, and 1. And don't forget, we read that colon as the word 2. So still a 2-to-1 ratio. Or if I write it as a fraction, whichever one comes first becomes my numerator. So it would be a 2/1 or a 2-to-1 ratio. But the second type of relationship, that we can represent here is a part to whole. So if I'm making a floral arrangement, everything that's going in there is a flower. So the carnation is a part of that floral arrangement. It's a part of all of the flowers that are in there. So a part to whole, I could have carnations to the total amount of flowers. So I know that I have two carnations. But here's where I have to think. The total flowers. So if there's two carnations, there's one rose. So that makes a total of 3 flowers. So that would be a 2-to-3 total. And again, I can write that all my different ways. I can use the word 2, or I can write that as a fraction. Now, if I want to take this one step further, I'm going to create a different one. Let's say I want the ratio of the total flowers to roses. So if I said total flowers to roses, I have to think, okay, well, is this a part-to-part or a part-to-whole relationship? Well, this one is a part-to-whole relationship because I have all of the flowers involved. Now, since it wants the total flowers first, I would have to write the 3 first. To the roses, well, there's only one rose out of those 3. So I have a 3:1, a 3-to-1, or a 3-to-1 in fraction form. Now, when we start setting up ratios, yes, it's great to know the original ratio, but we're going to spend a lot of time creating what we call equivalent ratios. Now, don't forget, we've used that word equivalent a lot before. Equivalent means that it means the same, it just looks different. So means the same, looks different. So there are a few places and a few ways that we can solve for these equivalent ratios. The first one says that two equivalent ratios can have the same multiplicative comparison. Now, I'm going to use some really fancy words here. We're going to get the definitions done, and then I'm going to go back and make this a little bit simpler. So that means that we're looking for a multiplier within a ratio. So if I have 10 apples can make me 2 pies. My multiplier to go from 10 to 2 would be times 1/5. So the number of pies is 1/5 the number of apples. But if I wanted to go from pies to apples, my multiplier there would be times 5. The number of apples is 5 times the number of pies. If you're ever unsure, replace the words with the numbers. So instead of saying the number of apples, I could say that 10 is 5 times the number of pies, which is 2. So that is true. 10 is 5 times 2. Or the other way we can look at it is we can look at two equivalent ratios, and they're always going to have the same factor of change, which means the multiplier between the ratios is the same. So if I wanted to go from 10 to 20, that would be times 2. Or if I wanted to go the other way from 4 to 2, that would be times 1/2. Okay. Again, that was a lot of really fancy words, a lot of really fancy ways to think about it. But we have talked about something before called a scale factor. If you remember when we talked about scale factors, we said there were two places that we could find a scale factor. And that is we could look within or we can look between. I did not spell between right. Try that again. Between. Now, these are words we're familiar with. We just saw them up here. Is that we're going to find multipliers within a ratio and multipliers between a ratio. So that's really all we're looking for is we're looking for two scale factors, something that takes me from one number to another, from one number to another.